Hello everyone. Today's program is Six Sigma in 60 Industries, Level 1. In this program, we are going to learn about application of Six Sigma in 60 different industries. Now let me explain about myself. I am Dr. D. Kanaharaj. I am a dentist with postgraduate diploma in management from IIM Lucknow, India. I'm a master black belt in Six Sigma with 15 years of experience in process consulting and training across industries like BPO, IT, ITES, hospitality, manufacturing, and healthcare. Now, let us get to know about this video. This video would give simple and basic idea about Six Sigma application in different industries. The target audience for this video would be professionals with some basic knowledge about statistics like mean and standard deviation. No formulas were used in this video to reduce complexity. The data used were mostly whole numbers to reduce complexity and unveil strong fundamental. The training program was designed keeping in mind the definition for a Six Sigma process, a process which has 6 standard deviations between mean and specification limits. The complete program is based on this definition, that is, Six Sigma process is a process which has 6 standard deviations between mean and specification limits. Now, let us learn what is a 3 sigma process. We all know that sigma stands for standard deviation. Now we are going to assess how can we call it as a 3 sigma process. This data is actually the data of registration time that is collected in a hospital. As we all know, registration time should be reduced. For registration time in a hospital, the hospital has fixed a target at 14 minutes. That we can see at the upper specification limit at 14 minutes. The current average, that the mean level of this registration process is 8 minutes. And now the standard deviation that is calculated for this particular process is 2. Now the difference between the upper specification limit and the mean is 6, that is 14 minus 8, it is 6. In 6, how many standard deviations can be accommodated? Between this 14 and 8, the difference is 6, and in this 6, how many standard deviations can be accommodated is 3 standard deviations. And as I said before, since only 3 sigmas can be accommodated between mean and the target, that is your upper specification limit, we say that this is a 3 sigma process. Now, let us consider that we have made some improvements in the same registration process so that the mean level have come down to 7 minutes and the variation have also reduced to with a standard deviation of 1.75. Now, considering the difference between the upper specification limit and the mean, the difference is 7. In 7, how many standard deviations can be accommodated? It is 4 standard deviations can be accommodated. That is the reason it is 4 sigma process. Now, coming to the 5 sigma process. Again, after taking some more actions and implementing some solutions, we have reduced the mean to 6 and the variation also have reduced to 1.6. The standard deviation is 1.6. Now the target is at 14 and your mean is at 6. The difference between your mean and the target is 8. In 8, how many standard deviations can be accommodated? It is 5. So it is 5 standard deviations can be accommodated. So it is 5 sigma process. Now coming to the last, what is a 6 sigma process? Here again, after some improvements, your mean level has again come down. It is 5 now and your standard deviation is 1.5. The difference between mean and the upper specification limit is 9. In 9, there could be 6 standard deviations that can be accommodated, and that's the reason it is 6 sigma process. So, a 6 sigma process is a process where your variation is reduced and the difference between the mean and your standard mean and your specification limit is only 6 standard deviations. So as your variation reduces, as your standard deviation is value comes down, more number of standard deviations can be accommodated between mean and your target. So that is the major focus of a 6 sigma process, where we are reducing variations and we are bringing out the mean within the specification limits. Now using this understanding, we are going to learn 6 sigma in different industries. Let us see the first industry or the vertical, that is accounts. Let us see now how we can implement 6 sigma in accounts vertical. The topic I have selected is reducing average accounts receivables more than 30 days percentage from 28% to 10%. As we all know, this is one of the major financial indicators for any organization to have as less as to reduce the days to receive the accounts receivables, or to receive the accounts receivables as fast as possible. Okay, so now this organization has 28% of the accounts receivables more than 30%, and they want to reduce it to 10%. This is a project topic. Now your target, what is the target? You want to reduce it to 10%, so that is upper specification limit. Since we are reducing accounts receivables, we have an upper limit, so that we don't want the accounts receivables to go beyond 10%. The current level that we have, that's the mean level that we have, is 28%, and standard deviation is 12. Now let's calculate the sigma level for this process. So what is the sigma level for this process? When we see the difference between the mean and the specification limit, when the difference between mean and the specification limit, it is 12. In this, how many standard deviation can be accommodated? We already know the standard deviation is 12, so we can only accommodate one standard deviation in this process. So this project, reducing accounts receivables percentage, the level of sigma that the organization is performing is sigma level 1. So they have to still improve this process from this 1 sigma level to achieve 6 sigma level. Now we'll discuss about how to apply 6 sigma in advertising industry. The topic that I have selected is reducing cost per enquiry per advertisement from $7,500 to $5,000. So as we all know, it is very essential to increase the number of inquiries at the same cost. So when we increase the number of inquiries at a very less cost, that is less budget, the cost per enquiry per advertisement will automatically reduce. So this helps us in assessing how does the advertisement need for particular campaign is effective and how to effectively reduce the cost per inquiry. Now in this example, our goal is to reduce the cost. So anything, if you're going to reduce, it is upper specification limit. So the target, that is upper specification limit, is 5,000, and the mean level, after making some improvements in the process, we have achieved a mean level of 4,800 from 7,500. So the current mean level that we have is 4,800 and the standard deviation that we have is 50. So now, looking at the difference between the upper specification limit and the mean, we have the difference is 200. In this 200, how many standard deviations can be accommodated? There are 4 standard deviations can be accommodated. In 200, we can accommodate 4 50s. 4 sigmas can be accommodated. So this is the 4 sigma process. Still, this process had to be improved by reducing variations and reducing the mean so that we can increase the sigma level to 6 sigma level. Now, the next industry that we are going to discuss is aerospace industry. In aerospace industry, reducing defects is one of the very important performance indicator. So we have selected reducing defects percentage. Let us consider that in this organization, the defects percentage was somewhere around 15% and they want to reduce it to 10%. So since it is reduction, as we have seen before, for reduction, for anything to reduce, we have upper specification limit and the mean is 15%. There with a standard deviation of 2.5. So the difference between the upper specification limit and mean is 5. In 5, how many standard deviations can be accommodated? We can accommodate it 2 standard deviations. But here, the sigma level is minus. What is the reason the sigma level is in minus, in negative? We have our target as 10%, but our mean is more than the target. It is beyond the upper specification limit. So whenever your data is going beyond the specification limit, if it is an upper specification limit, then that gets negative values. That's the reason here the sigma value is totally negative. So if your data is deviated from the target, if the data is deviated from the target or away from the target, then the sigma level is usually in negative. Now, the industry that we're going to discuss is agriculture industry. The topic that is selected is increasing yield percentage from 70% to 80% per acre. Now, in this example, the lowest specification limit. Since we are increasing the yield, we don't want the yield to go below 80%. So the target is 80%. We don't want the yield to go below 80%. So we fix that as lowest specification limit. Now, the mean is 76%. The mean level is 76%. And the standard deviation that we have is 1.33. Now, looking at the difference between the lowest specification limit and the mean, how many standard deviations can be accommodated? It is only 3 standard deviations can be accommodated. But as we saw before, since 76 our mean value is less than the lowest specification limit, it is in minus. As I already said to you before, if you have lowest specification limit, all the values that you get should be beyond lowest specification limit. It shouldn't come below the lowest specification limit, but in this situation, the mean of this particular process itself is below the lowest specification limit, and this is the reason for the sigma level to be presented in negative. So that is minus 3. Airlines. Let's see how to apply Six Sigma in airlines. The topic that we have selected here is reducing average waiting time from 40 minutes to 30 minutes. So as we all know, waiting time is one of the major indicators followed in airlines. Let us discuss about how to read sigma level in an airline example. So our target is 30 minutes. We are fixing that as our upper specification limit. Let us consider the mean value for us is 29 minutes. Okay, the mean value is 29 minutes and the standard deviation is 0.33. Now the difference between the upper specification limit and the mean value is just 1 minute. In 1 minute, how many 0.33 could be fitted or accommodated? It is only 3. So the sigma level for this particular process is 3 sigma level. So as I already said you before, airlines is one of the major industries which needs high customer satisfactions. So other than this average waiting time, we have other topics like increasing the customer satisfaction, reducing safety mistakes. So these are some of the other topics that you can think about doing projects in airlines industry. Now coming to architecture, reducing design cycle time. So architecture, the total cycle time for designing is very essential. So we have taken that as our project topic. Here, reducing design cycle time from 1450 minutes to 1200 minutes is our goal. The upper specification limit is 1200 minutes. So target is 1200 minutes. Let us consider that our mean level design cycle time mean level is 1080 minutes. Now here in this process, the difference what we have between mean and the upper specification limit is 120 minutes. In 120 minutes, how many standard deviations can be accommodated? The standard deviation value is 20. So the number of standard deviations that can be accommodated is 6. That's the reason it is a 6 sigma process. So as we already saw, 6 sigma process is a process which has 6 standard deviations between mean and target. Now coming to the law industry, the example that we are discussing is increasing the percentage of cases solved from 50% to 60%. So solving the cases is the primary objective of legal law industry. If you want to increase the percentage of the cases solved, the specification limit that you will get is lowest specification limit. So now that our target is 60%, that is the lowest specification limit. Let us consider the mean is 80%. Okay, they have well performed beyond the lowest specification limit, 80%. Now standard deviation is 20. The difference between mean and the lowest specification limit is only 20. And how many standard deviations can be accommodated in 20? Only one. So it is a 1 sigma process. Now, the energy industry, that is power industry. We have selected reducing deviation percentage in actual versus expected power production from 7% to 5%. As we all know, in power industry, power production is one of the major essential requirements. If that is not happening as per the plan, how much is it happening? That is what we are measuring in this project. Since it is reducing, we have upper specification limit, that is at 5, that is the target. Our mean value is at 4.5. So the difference between the specification and mean is 0.5. Between 5 and 4.5, which is 0.5, how many standard deviations can be accommodated in 0.5 is just 1. So it is in sigma level 1. Now the next industry that we are going to discuss is automotive industry. In automotive industry, the project that we have selected is overall equipment effectiveness. Overall equipment effectiveness is a significant performance indicator to measure the performance of machines installed in an organization. OEE is calculated based on availability of your machines, the performance of your machines, and the quality output of your machines. Now in this example, we have a goal of increasing the overall equipment effectiveness from 80% to 85%. So the lowest specification limit is 85, the mean value is 75. The difference between the mean and the lowest specification limit is just 10. In 10, how many standard deviations of 2.5 could be accommodated? It is 4. So the sigma level for this particular process is 4. The next industry is banking industry. Application of Six Sigma in banking industry. The project is reducing loan processing time from 600 hours to 500 hours. Here, the specification limit, that is the upper specification limit, is 500. We don't want the loan processing time to go beyond 500 hours. The mean level is 450 hours. Standard deviation is 10. The difference between mean and the specification limit is 50. In 50, there could be 5 standard deviations that could be accommodated since the standard deviation is 10. So it is 5 sigma process. Now let's see how to apply Six Sigma in financial investments. Since it is financial investments, increasing the number of customers is very important. So we have taken that as a project here. Increasing the average value of new customers from $5,000 to $6,000. Here the lowest specification limit is 6,000. The mean level is 5,000. The standard deviation is 1,000. The difference between mean and the lowest specification limit is only 1,000, and we can accommodate only one standard deviation, that is only 1,000 between these two limits. So it is 1 sigma level. Now coming to restaurants. Reducing cost is very essential in restaurants. We have taken the reducing the average cost per meal from $75 to $60. Here the upper specification limit is 60. The mean level is 75. The mean level is beyond the upper specification limit. So when we say it is an upper specification limit, we don't want the average cost per meal to go beyond $60. But here the mean level is beyond $60, it is at 75. So the difference between mean and the specification limit is 15 and standard deviation is 5. But since the mean is beyond the specification limit, it is not plus 3 sigma level, it is minus 3 sigma level. Now, we'll see how to apply Six Sigma in publishing industry. Errors is very important and it needs to be reduced in publishing industry. So reducing the average number of errors from 25 to 20 is the project that we have selected. Here the upper specification limit, the target is 20. Let us consider that the mean is 18. So the difference between 18 and 20 is 2. The standard deviation is 0.5. In 2, there could be 4 standard deviations that could be accommodated. So the sigma level is 4. Coming to the media industry and its Six Sigma application. Reducing the average customer acquisition time from 1000 hours to 750 hours. Here, the upper specification limit is 750 hours. The mean level is 1000 hours. The standard deviation is 50. The difference between the upper specification limit and mean is just 250. In 250, we can accommodate 5 standard deviations, but since the mean level is beyond the upper specification limit of 750, we are having here minus 5 sigma level. Construction industry Six Sigma application. Defects is very important in construction industry, and now we are going to focus on reducing time taken to fix defects. So the project topic is reducing time taken to fix defects from 90 hours to 70 hours. Here the upper specification limit is 70. The mean level for the fixing the defects is 60. Standard deviation is 2. Here the difference between the upper and the mean level is just 10, and we can accommodate 5 standard deviations, that is we can accommodate 2. How many 2 can be accommodated is only 5, so it is 5 sigma level. Six Sigma application in chemical industry. The topic that we have selected is reducing lost time after injury from 1300 hours to 1000 hours. So injury is very common in chemical industry, and how are we reducing the lost time after injury? So that is what we are discussing here. In this project, the mean level is 900, the upper specification limit is 1000. Here the standard deviation is just 50. So the difference between the upper specification limit and mean is 100, and the sigma level is 2 because we can accommodate only 2 standard deviations, that is 250s between mean and the upper specification limit. Education industry and its Six Sigma application. Increasing the yield per student from 88% to 95%. Bringing out more effectiveness and efficiency among students is very important in education. That's the reason we have selected this topic. Here, since we are going to increase the yield per student, it is lowest specification limit. The target is the lowest specification limit, that is at 95. The mean level is at 88. Standard deviation is 3.5. So between 88 and 95, we have a difference of totally 7. And in this 7, how many standard deviations can be accommodated is only 2, because the value of standard deviation is 3.5. So it is a 2 sigma level process that we have in this particular example. In the garment industry, application of Six Sigma. Machines. Machine is very important in manufacturing and also in garment industries. So here we are taking this very essential project, that is reducing downtime of machines. So reducing downtime of machine from 70 hours to 50 hours. Here the upper specification limit is 50, the mean level is 48, the standard deviation is 1. The difference between mean and the upper specification limit is 2, and we can accommodate just 2 standard deviations between mean and the target, so it is 2 sigma level. Coming to the IT industry and its 6 sigma application, customer compliance is very important here. So we have taken this particular project, reducing the ticket resolution time from 150 minutes to 120 minutes. So how much time is taken for people in a software company to resolve a ticket, that is the complaint. So that is what we are focusing here. Here the target is 120, the mean level is 110, the standard deviation is 10. The difference between mean and the target is just 10. We can accommodate only 1 standard deviation, so it is a 1 sigma process. Coming to dairy industry, increasing the average percentage of productive cows from 90% to 95%. That's a topic we have selected. Here the lowest specification limit is 95, the mean level is 97. The difference between mean and the lowest specification limit is 2. The standard deviation is 0.5. In 2, we can accommodate 4.5s, so it is the 4 sigma level process. Now coming to purchase department and its 6 sigma application, reducing the purchase lead time from 1700 hours to 1200 hours. Here the target is 1200 hours, mean level is 1120, so the difference is 80. Standard deviation is 40. In 80 we can accommodate just 2 standard deviations of 40, so the sigma level here is 2. Dentistry and its 6 sigma application. Patient satisfaction is of utmost importance in dentistry, so we have taken that example. Increasing the patient satisfaction percentage from 95% to 98%. The target is 98. Mean level is 97. The mean level is less than the lowest specification limit, and we have a standard deviation of 1. So here the difference between mean and the target is 1, and we are lesser than the lowest specification limit, so we are not achieving the target. So the sigma level is in minus, because only 1 sigma can be accommodated. It is in minus 1 sigma level. Now 6 sigma application in medical industry, especially for doctors, increasing the surgery success rate from 92% to 95%. Here the lowest specification limit is 95. The target is 95. We don't want the success rate to come below 95%. The mean level is 97. It is beyond 95, beyond our target, and our standard deviation is 0.5. The difference between 95 and 97 is 2, and we can accommodate 4 standard deviations because the standard deviation level is 0.5, and the sigma level that we have is 4. 6 sigma application in electronics, reducing the average delivery time from 800 hours to 700 hours. So here we are reducing the delivery time. The upper specification limit is 700. Target is 700, mean is 650, standard deviation is 50. Here the difference between mean and the upper specification limit is just 50, and we can accommodate only 1 standard deviation in this, so the sigma level is 1. Coming to real estate industry, the most prospective industry, reducing the average time to sell from 1000 hours to 750 hours. So how much time are we taking to sell a product? So that is what we are discussing here. So the upper specification limit is 750, mean is 1000, standard deviation is 250. In the difference between mean and the specification limit is 250. In 250 we can accommodate only one standard deviation of 250, so it is 1 sigma level. Coming to hospital industry, reducing the average discharge time from 45 minutes to 30 minutes. Here, the upper specification limit is 30, the mean level is 28, standard deviation is 1. In the difference between the mean and the upper specification limit, that is 2, we can accommodate only 2 standard deviations. So it is a 2 sigma process. In insurance, reducing the average time to claim from 60 minutes to 45 minutes. Here, the upper specification limit is 45, the mean level is 15, standard deviation is 5. So the difference between mean and the specification limit is 30. In 30, how many standard deviations can be accommodated? It is 6, so it is at 6 sigma level. Now, let's see how to apply 6 sigma in music. Errors is one of the major requirements that needs to be reduced in music. Reducing the error rate from 7% to 5% is the project that we have selected. So here, the upper specification limit is 5, the mean level is 7. The mean level is beyond the upper specification limit, and the difference is 2, the standard deviation is 1. In 2, how many standard deviations can be accommodated is only 2, but since the mean level is beyond the upper specification limit, we are calculating it as minus 2 sigma. In the mining industry, let's see how accommodate 4 standard deviations, so it is 4 sigma level. Six Sigma application in food processing industry. Rejects percentage. Reducing the rejects percentage is the topic we have selected, and we are reducing it from 6% to 4%. Here the target is 4, mean level is 3.5, the difference between mean and the target is 0.5, standard deviation is 0.25. How many standard deviations can be accommodated between mean and the target? It's only 2, so it is a 2 sigma level. Telecom industry. Increasing the quality percentage from 90% to 96%. The lowest specification limit is 96. Mean level is 98. Standard deviation is 0.5. We can accommodate 4 standard deviations between mean and the target, so it is 4 sigma level. Six Sigma application in BPO. Reducing the average handling time of customers from 10 minutes to 7 minutes. The upper specification limit is 7. The mean level is 5. Standard deviation is 1. In the difference of 2 between mean and the target, that is upper specification limit, we can accommodate 2 standard deviations, so it is 2 sigma level. Medical coding industry. Reducing the coding error from 5% to 4%. The target is 4. The mean is 3. Standard deviation is 1. In the difference between the mean and the upper specification limit, that is 1, we can accommodate only 1 standard deviation, so the process is at 1 sigma level. Medical billing industry. Reducing the average billing time from 80 minutes to 60 minutes. Here the target is 60. The mean level is 80. The mean level is beyond your upper specification limit. It is not reaching your target. The standard deviation is 4. The difference between the mean and the specification limit is 20. In 20, there could be 5 standard deviations that could be accommodated. But since the mean level is not reaching your target, here it is in minus 5 sigma level. In retail industry. Increasing the bill value per customer from $500 to $750. The lowest specification limit is 750. The mean level is 800. The difference between mean and the target is 50. Standard deviation is 25. In 50, there could be 2 standard deviations that could be accommodated, so it is 2 sigma level. Logistic industry and its 6 sigma application. Increasing the percentage of right time delivery from 85% to 90%. Here the lowest specification limit is 90. The mean level is 93. Standard deviation is 1. In the difference between the mean and the specification limit, that is 3, we can accommodate 3 standard deviations, so it is 3 sigma level. Coming to the travel industry and its 6 sigma application. Reducing the cost per travel from $100 to $90. Here the target is 90, the mean level is 80. It is well within the target. Standard deviation is 2. In the difference between the mean and the target, that is 10, we can accommodate 5 standard deviations. 5 2s can be accommodated, so it is 5 sigma process. Sales. The most important indicator in sales, conversion rate. Increasing the average conversion rate from 25% to 35%. The target is 35, the mean level is 40, so our conversion rate is well beyond our target. Standard deviation is 2.5. Here the difference between the mean and the target is just 5, and in 5 we can accommodate 2 2.5s, 2 standard deviations. So here the sigma level is 2. Coming to the packaging industry. Reducing the average packaging time from 30 minutes to 20 minutes. Here the upper specification limit is 20, the mean level is 18, standard deviation is 1. In the difference between the mean and the upper specification limit, that is 2, we can accommodate only 2 standard deviations, so it is 2 sigma process. Biotechnology, reducing cost of poor quality percentage from 5% to 4.5%. So cost of poor quality, target is 4.5, the mean level is 3.5, the difference between mean and the target is 1, standard deviation is 0.5, there could be 2 standard deviations that can be accommodated here, so the sigma level is 2. Six Sigma application in pharmaceutical industry. Reducing the average time to develop new drugs from 10,000 hours to 9,000 hours. In this example, we can see that the upper specification limit is 9,000, the mean level is 8,000, standard deviation is 1,000. So in the difference between the mean and the target, we can accommodate only one standard deviation, so it is in 1 sigma process. Coming to design industry, reducing the design error percentage from 5% to 4%. Here the upper specification limit is 4, mean level is 3.5, standard deviation is 0.1, so that there could be 5 standard deviations of 0.1 that could be accommodated between 4 and 3.5, so it is in 5 sigma level. Hardware industry, reducing the server failure rate from 1% to 0.5%. Here the upper specification limit is 0.5%, mean level is 1%, standard deviation is 0.5. We can accommodate only one standard deviation between mean and the target, so it is 1 sigma level. Six Sigma application in photography, reducing the cost per photo from $1,500 to $1,000. The upper specification limit is 1,000, the mean level is 900, standard deviation is 50, sigma is 2 because in the difference between mean and the upper specification limit, that is 100, we can accommodate only 2 standard deviations of 50. Now let's see how to implement Six Sigma in government. In governments, resolving complaints is very important, so we have selected this, reducing the time to resolve complaints from 1,200 hours to 900 hours. Here the upper specification limit is 900, the mean level is 1,200, so they are not reaching their targets. It's beyond the specification limits. Now let's see how to apply Six Sigma in NGO. Increasing the budget compliance percentage of projects from 90% to 95%. Lower specification limit is 95, mean is 98, standard deviation is 1. So in the difference between mean and the target, which is 3, we can accommodate only one standard deviation, so it is a 3 sigma level. Now coming to consulting industry, increasing the average customer retention time from 18,000 hours to 20,000 hours. The lowest specification limit is 20,000, the mean level is 29,000, the difference is actually 9,000, standard deviation is 3,000, so only 3 sigmas can be, standard deviations can be accommodated, it is a 3 sigma level. Six Sigma application in facility management, reducing the average customer acquisition time from 130 hours to 100 hours. The upper specification limit is 100, the mean value is 86, the difference is 14, standard deviation is 7. So in the difference between mean and the upper specification limit, we can accommodate only 2 standard deviations, so it is a 2 sigma level. Now, Six Sigma application in research and development. Increasing the percentage of successful trials from 90% to 95%. Lowest specification limit is 95, but the mean is only 90. We are not able to achieve the targets. Standard deviation is 1. The difference between mean and the lowest specification limit is 5, and the standard deviation is 1. So we can accommodate 5 standard deviations between mean and lowest specification limit. But since the mean is less than the specification limit, we have -5 sigma level. Now, Six Sigma application in forestry. Reducing the average number of wildfires from 20 to 15. The upper specification limit is 15, mean is 14. Standard deviation is 0.25. So in the difference between the mean and the upper specification limit, we can accommodate only 4 standard deviations, so it is at 4 sigma level. Six Sigma application in fisheries. Increasing the average yield from 90% to 95%. Here, the lowest specification limit is 95. The mean level is 97, standard deviation is 1. So in the difference between 97 and 95 is 2, and we can accommodate 2 standard deviations of 1 in between mean and the lowest specification limit. So the sigma level is 2. Now coming to archaeology. Reducing the time to discover from 12,000 hours to 10,000 hours. So the upper specification limit, the target is 10,000. The mean level is 9,800. The difference is 200. Standard deviation is 200. So we can accommodate only 1 standard deviation between mean and the upper specification limit. So it is at sigma level 1. Wood and furniture. Reducing the delivery time from 60 hours to 50 hours. The upper specification limit is 50, mean is 45, standard deviation is 1. We have a sigma level of 5 because in the difference between mean and the specification limit, the difference is 5, and in that only 5 standard deviations can be accommodated, so it is 5 sigma level. Now recruitment. Reducing the cost per hire from $500 to $350. Upper specification limit is 350. The mean level is 355. Standard deviation is 1. The difference is 5, and we can accommodate 5 standard deviations. But since the mean level is beyond the upper specification limit, it is in minus, so it is -5 sigma level. In repair and maintenance, reducing the average repair time from 6 hours to 4 hours. The difference between mean and the upper specification limit is 0.2. The standard deviation is also 0.2, so we can accommodate only 1 standard deviation between mean and the target, so it is at 1 sigma level. Housekeeping and its Six Sigma application. Increasing the cleaning adherence percentage from 97% to 98%. The lowest specification limit is 98. Mean level is 98.2. The difference is 0.2. Standard deviation is 0.1. Sigma level is 2. Cleaning adherence percentage is nothing but how far the cleaning people are able to adhere to the schedule that they have prepared every day. So are they adhering to the schedule of cleaning? That is what is cleaning adherence percentage. Six Sigma application in warehouse. Increasing the capacity utilization rate from 90% to 95%. The lowest specification limit is 95. The mean level is 96. Standard deviation is 0.33. we can accommodate 3 standard deviations between 95 and 96. So it is a 3 sigma level. Thank you for watching this video. This video would have given you an idea about how to implement Six Sigma in different industries. This is only an awareness video. If you want a detailed study on how to implement Six Sigma specific to industries, always keep connected with me in contact@pathmaker360.com. My name is T. Kanaharaj. Thank you very much.